Hi, everyone. Welcome. We're pleased to have you join us for the Sharing Ocean Acidification Resources for Communicators and Educators, or SOARCE webinar today. Our series is presented by the NOAA Ocean Acidification Program in collaboration with the National Marine Sanctuaries. Our goal is to provide ocean acidification communication tools to formal and informal educators and stakeholders and rights holders across the country to promote a more integrated and effective ocean acidification education community. My name is Natalie Lord, and I'm the Capacity Building and Engagement Knaus Fellow at the Ocean Acidification Program, and I will be facilitating today's session. Today, during the presentation, all attendees will be in listen-only mode. We are recording this presentation, and it will be available on our YouTube channel, which I will share the link to shortly after. You are welcome to type any questions or comments into the questions control panel, and we'll be monitoring incoming questions and respond to them or pose them to our speaker at the end of the presentation. Any comments or responses can also go into the chat. So before we start, we'd like to get to know who is attending today's webinar. So if you could please take a minute to answer this poll that describes who you are. I'll give a few minutes. Okay, so we have students, coastal managers. Give a few more seconds and then share the results with you. Okay, so it looks like we've got a good mix here. So we've got educators, researchers, coastal managers, and students attending today. Thank you all for being here. All right, so next I'd like to introduce our speaker, Val Brown. Val has worked with NOAA in the Pacific Islands region since 2004 and has participated in a wide range of projects from coral reef monitoring and assessment to developing response plans and community monitoring programs, as well as coordinating ridge to reef restoration efforts. As the research coordinator for the National Marine Sanctuary of American Samoa, Val leads the conservation science program and efforts to better understand and protect the amazing reefs at Fagatele Bay, the Valley of Giants, Rose Atoll, and Swains Island, and the ecosystem services that they provide to the people of American Samoa. Thank you, Val. And with that, we'll start the presentation. So I'm going to make you the presenter.
All right. Well, good morning, everyone. Tayo Manuia and Talofa. See if we can get our screen sharing here. Hopefully you can see that now. Natalie,
Yep,
give me a
looks
thumbs
great.
up if we're good. Excellent. All right, so good morning from American Samoa. My name is Val Brown. I'm the research coordinator here at the National Marine Sanctuary of American Samoa. Today, I'm going to share my experiences with storytelling as a tool to share information, and I will then tell you a story I've made about ocean acidification and a little bit about how I crafted that story. So I've been working in the Pacific for a long time now, and one of the things that I've come to value is the tradition of talking story. So sharing experiences and observations in an informal fashion. Storytelling here is an important and powerful tool to engage people. So today, all of you are invited to join me on my first attempt to tell a story about some special places and how ocean acidification may change them. Ocean acidification, has been a particularly difficult concept for me to put into story. I can't easily show it to people. It's happening really slowly and with incremental changes over time. So most casual users might not see the warning signs until it's too late and until we see some sort of catastrophic loss. So let's dive in and see how I deal with those constraints. And at the end, I'll walk you through how I crafted my messages, the tools I used, and we can discuss if the story resonated with you and maybe suggestions on how I can make it better or make it more useful for broader audiences or people to deliver. So let's get started. So, talofa. My name is Val Brown. I'm the research coordinator at the National Marine Sanctuary of American Samoa, one of 15 national marine sanctuaries designated across the country to protect special places. The sanctuary program seeks to protect the extraordinary scenic beauty, biodiversity, historical connections, and economic productivity of these areas so that they may continue to serve as the basis for thriving recreation, tourism, and commercial activities that drive our coastal economies. Today, I'm going to take you on a little bit of a journey all the way down to the South Pacific. So far away from the continental US, where the only inhabited US territory south of the equator lies. And this is where you will find the National Marine Sanctuary of American Samoa. The sanctuary covers 13,581 square miles from our 2 units on the west coast of Tutuila, the islands of Vanu'u, and then stretching all the way east to the remote Rose Atoll and the Rose Atoll Marine National Monument in our Moliava unit. Stretches also up to Swains Island in the far north, about 200 miles away. The sanctuary includes a tremendous amount of biodiversity, both in habitats and species. It extends from the beach all the way to the deep sea and includes all the different types of habitats in between. It's truly an amazing place, and I'm so blessed to work here. But today, I'm going to take you to the island of Ta'u, our 6th unit, and a very special coral that lives in the sanctuary unit there. And here it is. This is one of my favorite corals in the whole world. Many people call it Big Mama, sometimes Falebame, because it is a huge coral that is as big as a house. So it's really hard for people to comprehend just how large this animal is until you're right up next to it. So I do invite all of you to check out our website to take a close-up view of this 360 dive at Big Mama. And I think we can put the link into the chat for you all. So we have this 360 viewer that you can actually steer around, take a little tour of this coral. But just to give you an indication of size right now, this coral is 6 meters high. It's over 40 meters around, and it sits in about 12 meters of water. So it can easily be seen from the surface. And I just want you guys to think about this here. Given its tremendous size, how old do you think Big Mama is? I think it's like a 10-year-old coral, 100, 500, 1,000. You can type it in the chat if you like, so you have bragging rights for being correct, or you can just jot it down to yourself. And we're going to come through some steps on how we figured out just how old Big Mama is here in just a second. I do want to note, though, that this is not the only big coral in Ta'u. In 2019, I was part of a team that conducted a search around the island of Ta'u to locate other large corals, and we found a lot of them. And a number of those are located in the same area as Big Mama. Most of them are not as big, but we refer to this island as the Valley of the Giants. But oops, jumped there. But Big Mama wasn't always this big. It started out as a single coral baby drifting around the ocean looking for a place to settle. It probably sensed some coralline algae and other corals and directed itself down to the bottom of the reef where it found a nice, safe place to grow, transforming from that cute little free-swimming form to what I kind of refer to as a little coral dumpling before it fully developed into a coral polyp. I think they're adorable baby corals. But even a coral this big, it starts as a single polyp. And these polyps are simple animals. You can think of them as a tube with a mouth, a stomach, and tentacles that help them filter feed and defend themselves. For most corals, once they settle on the reef, they are stuck there permanently. They can use their tentacles to capture food that comes by, but since they can't swim to find food like other creatures or walk, they rely on a special plant that lives inside of their skin. And so this is a picture of a coral polyp. And if you could magnify that, inside you would see the zooxanthellae. I know you guys want to go ahead and say that to yourself out loud. If you're somewhere you can. Zooxanthellae. It's an incredibly fun word. You'll also hear me refer to them as zoox in this talk. And you can think of these zoox as tiny little greenhouses living in the coral. They use sunlight and carbon dioxide to produce food and energy, which the corals then use to grow. In fact, about 90% of a coral's nutrition is produced by zooxanthellae. And these also give the corals their beautiful, beautiful colors. As the polyps grow, they create calcium carbonate skeleton underneath them that supports and protects them. Over time, the colony expands in size, making room for new polyps that are the exact replicates of the original. Big Mama has been at this for a very long time now. It's coming soon, and now has millions of polyps. And each one of them secretes calcium carbonate to help the colony grow and expand. This happens inside the corals, where corals can control the conditions. So they pump in calcium and carbonate ions to form the calcium carbonate. And keep in mind, this is the same material as chalk or antacid tablets that you might find in your home or school. And this calcium carbonate is laid down layer by layer under the polyps. Now, if there is not enough carbonate ions in the water, the coral can use energy supplied by its zoox to break down bicarbonate ions, and then they export the extra hydrogen ions out of its tissues. So this is energy intensive because they have to break the bonds apart. And the latest research suggests that the zoox play an important role in powering this process. So they're not just providing food, they're also helping the corals build their skeletons. In some corals, like Big Mama, you can actually trace this growth over time. So in 2011, scientists drilled through the middle of the coral to find out just how old the colony is and to look for clues about the area's climate history. The core was carefully extracted and a CT scan was conducted, as well as some chemical testing using oxygen isotopes. And we now have the answer to that question of just how old is Big Mama? Well, the answer turns out to be that it is over 500 years old. The core goes all the way back to 1520. But it's important to know that that may not include the original base of the coral, so it could be even older. Scientists were able to line all of these bands up with environmental conditions and investigate how changes over time, such in temperature and other conditions, affect the coral's growth. And you're actually able to see the growth of the coral, just like tree rings. Some bands are thick, some are thinner, and these seem to correlate with changes in weather conditions. One thing you should note is that these Porites corals grow very, very slowly, sometimes only 100 millimeters per decade. That's 1 centimeter per year. Other corals, like the branching acropa corals and that you see around Big Mama and at our other sites, some of those can grow up to 10 or even 20 centimeters each year. So this is a slow growing coral, it takes time, and all of the corals have to invest significant energy to grow these skeletons. And these corals are really important. So Big Mama and the other corals around it are an integral part of our sanctuary ecosystems. They provide structure and food for fish, and also a range of other invertebrates, including crabs and lobsters and even other corals. These in turn feed bigger fish and even humans. But that's not all it does. The reefs also buffer storm waves. A 2014 study found that reefs reduce about 97% of the total wave energy approaching our shorelines. The corals and coralline algae constantly grow to keep building and cementing the reef together. They are living coastal defenses for our islands. And this is a valuable service because most of our villages lie close to the water in a thin strip of flat land between the shoreline and the soaring mountains behind us. You can see here how the waves break up the energy far offshore and protect these vulnerable areas. And that is really important to another part of our sanctuary ecosystem, which is the people. Samoans have lived here for over 3,000 years, and the culture is intertwined with the ocean. It is part of the heritage. The ocean doesn't separate here, it connects. It is part of life. And Big Mama was born after the Samoan people settled here. So it has actually grown up right next to people, supporting them, protecting them, feeding them, and a silent sentinel there below the waves. And we're so blessed here because our coral reefs are in good condition. We have heard horrible stories this summer about the condition of reefs in other places, but here they continue to protect our shorelines, provide sustenance for the community, and support a number of cultural practices. But what if that changed? What if instead of looking like this, the reefs instead looked like this? What if the corals could no longer build their skeletons? What if the reef structure itself actually started to dissolve? When I started my career, I thought that this type of damage would only happen from pollution or ship groundings or dynamite fishing. But now I worry that it could eventually happen even in our most remote, seemingly pristine sites. And the reason for that is a process known as ocean acidification. I think a lot of you may know that the ocean absorbs carbon dioxide from the atmosphere. For those of you familiar with chemistry, this is back to Chemistry 101. This is an equilibrium reaction. The atmosphere and the ocean are balancing each other. And at first we kind of thought this was a great thing. The ocean is huge, right? It can store some of that carbon dioxide, no problem. But there's a problem with that. And the problem is that carbon dioxide reacts with seawater to create carbonic acid. And that means that more carbon dioxide in the air equals more carbonic acid in the water. And we can't see this happening, but we can measure it. And those measurements tell us that increasing carbon dioxide is lowering the pH of seawater, and the oceans are increasing in acidity. Let's take a look at the data here. So NOAA has been monitoring carbon dioxide at the Mauna Loa Observatory since 1958. In this graph, carbon dioxide in the air is shown in red, and you can use the scale on the left of the chart to see how it has changed from about 320 parts per million in 1958 to over 400 parts per million in 2018. It is now hovering around 420 parts per million. The green line is seawater carbon dioxide, and it has followed a similar trend since measurements started in the 1980s, again, increasing over time. The blue line shows the pH, and you'll notice that the higher the carbon dioxide in the air and in the water, the lower the pH has gone. And this might not seem like a very big change. That looks like about 8.13 down to about 8.05, but this is a logarithmic scale. And so these changes reflect a 30% increase in the acidity of the ocean. And even here in such a remote location, we are not immune because the atmosphere and the ocean are connected. This is a graph from the Tula Observatory at the eastern end of Tutuila, the largest island in American Samoa. And what you'll see is that it shows a similar trajectory with carbon dioxide concentrations continuing to rise. And this is bad news for marine organisms. Many of you have probably seen these images. They're a stark reminder of what may happen if ocean acidification continues at its current pace. This is a pelagic snail shell that was exposed to ocean conditions expected in 2100. And you see that it dissolves over time, just a matter of 45 days. And scientists suspect that ocean acidification could affect many species and ocean food webs because of this. But a lot of uncertainty remains about what the effects will be on living organisms. I personally am particularly worried for animals like Big Mama, other corals, and giant clams that create calcium carbonate skeletons or shells. As the pH declines, it will become harder and harder for these animals to create their shells and skeletons. If you remember our coral skeleton chemistry equation from the beginning, these animals rely on carbonate ions. Well, as the ocean increases in acidity, calcifying organisms will have to spend more energy to access carbonate ions for calcification. Hydrogen ions in more acidified waters act like free agents. These free agents compete for carbonate, so carbonate ions will be less plentiful. And due to the higher concentrations of carbonic acid, more and more of these ions will be bound up as carbonate. And that means that corals will rely on the conversion of bicarbonate ions, which may eventually become too energy intensive for some corals to maintain. The good news is that the Porites corals like Big Mama, they seem to be particularly adept at this process. But for many corals, it may not be so easy. Researchers have found that most of the corals rely on their zooks to provide the energy required for these reactions. And as many of you know, because the oceans are also warming at high temperatures and high light levels, the zooks become toxic and the corals have to spit them out. The corals become white or sometimes fluorescent if they have protective proteins, and this is a phenomenon known as coral bleaching. So without the zooks, the corals can only capture food that floats by on the currents. They have to slow their growth, and they may become susceptible to disease and predation. So in this middle picture there, you see bleached corals, and they're alive. They still have all of their tissue, but they're unwell. And if the temperatures remain high for too long, the corals can even die. If the corals cool in time, the corals may be able to acquire more zooxanthellae, but they often grow slower because of that energy-intensive process for calcium carbonate creation, or they may delay reproduction for a few years. Like carbon dioxide, bleaching events have also increased over time. So in the past, in the 1980s to the early 2000s, these events happened once every decade. But more recently, we've witnessed bleaching events here in American Samoa in 2015, 2017, and 2020. And those bleaching events caused detectable changes in our reef systems. This includes a dramatic decline in branching corals at Swains Island, which also was exposed to severe heat stress in 2016. Now, Big Mama has survived these events so far, but other corals around it did not fare as well. And the good news, there's a little hope here. The good news is that there are signs of recovery, even at Swains. New corals are coming in and settling on the skeletons of the old ones, but it is possible that we will see another thermal stress event in 2024 or 2025 due to the strong El Nino that is developing. And there's some worry that these frequent events might not give corals enough time to recover. And if corals can't keep up with the sea level rise, if they can't grow their skeletons, we may see an increase in events like this, where storm waves flooded the power generator and blocked the roads to the school in Onu'u. This also puts this island's water supply at risk. And in addition, if the acidity continues to increase, it may also make it harder for our baby corals to find the reef, settle down, and build their skeletons, particularly for those that don't have any zooks when they settle. And we don't know what the effect may be on fish populations here. There are many, many questions. With over 1,000 species of fish, reef fish alone, there are many modes of life. They feed on different organisms, have different larval stages, and the adaptability to ocean acidification seems to vary widely and may depend on these life history characteristics and prey items. What we do know is that for now, the sanctuary offers a window into what coral reefs with minimal direct human impacts and reefs that have proven resilient to disturbance events like crown of thorns sea stars, coral bleaching, vessel groundings, and storms. And reefs that we know that, at least for now, they are doing okay. And researchers are trying to understand just why that is. So recently, the Pacific Islands Fisheries Science Center, including Dr. Hannah Barkley, recently visited Rose Atoll. Part of their work there measures how fast carbonate accretes over time at sites across the Pacific. They use tools like this calcification accretion unit. And these are simply plates secured on the reef that allow coral and algae to settle and grow. Every 3 to 5 years, the team removes the plates and measures them to see just how fast these organisms are growing and how much calcium carbonate they're secreting. This plate was in the water from 2018 until 2023 and is covered with coral and algae. You can see why coral and algae is so important to our reefs. It grows quickly and helps hold the reef together. It also provides important chemical cues for our baby corals. Data from that program, the National Coral Reef Monitoring Program, from 2008 to 2020 is summarized in our Sanctuary Condition Report that was released last year in December. But excitingly, the data are also now available through this data visualization tool. And this provides some helpful information for managers and for people that are just interested in reef health. Here I've got the climate dashboard pulled up. And if you look in the center, you will see a graph labeled aragonite saturation state over time. Aragonite saturation is a measure of how concentrated those calcification building blocks are in the water. Each species needs a certain saturation for it to be energetically efficient to build and maintain shells and skeletons. For corals, that level is 3. You can see here in this graph showing grab samples taken in 2015, 2018, well, 2015 and 2018 in this graph, you can see that Rose Atoll levels are closer to 4. And so that's good news. Reefs in Rose Atoll have the highest carbonate saturation that have been measured in the US Pacific. And that creates favorable chemical environment for coral reefs and other calcifiers. I will note that the saturation levels decrease as you move from Rose Atoll towards Tutuila, but they do remain well above 3 at all of the sites in American Samoa. And that gives us hope that Big Mama and other corals may offer solutions to help improve reef management. We are working with partners to implement research and management efforts here to better understand what is happening to our reefs over time. And we're thinking about adaptation strategies to help ease the effects of ocean acidification, both here and other places. One of the most important parts of this effort is this buoy. It is a moored autonomous partial pressure of carbon dioxide buoy, or a MAP CO2. And NOAA's Ocean Acidification Program, in coordination with NOAA's Atlantic Oceanographic and Meteorological Laboratory, the Pacific Marine Environmental Laboratory, NOAA Fisheries, and the Pacific Integrated Ocean Observing System, PAC-IUS, worked with the Sanctuary and local coral reef advisory group to establish this buoy in Fagatele Bay as a node in the National Ocean Acidification Monitoring Network. We are so grateful for OAP's support to enable this buoy, which is the only US ocean acidification buoy south of the equator. And it's a pretty amazing piece of scientific equipment. It measures a suite of key oceanographic indicators and transmits data multiple times a day. This is a big advantage over the past sampling efforts that we looked at, which only took place once every 3 to 5 years and require lab processing. And you can see this data yourself at the PAC IUS website. So there is an entire page dedicated to this buoy. It shows things like water temperature, salinity, turbidity, chlorophyll, oxygen, and the last two are important ones, pH and carbon dioxide data. And it provides a continuous stream, allowing us to observe daily cycles and changes over time. If you click on the Access button at the top of the website, you'll see links to other data streams and other long-term data sets. You can also access the data and other information through the PAC IUS Voyager page, which is an integrated map-based interface with a range of data sets that allow people to explore information. Here you can see the graph of the carbon dioxide data in the water. And this is a great resource for researchers and local managers. It allows us to really understand what's happening on our reefs here and to notice things like the diurnal cycle of carbon dioxide and pH that occurs on our reef on a day-to-day basis. For educators, this is also a great resource for accessing and visualizing real data right on a map, and it's definitely worth checking out with your students. But that's not the only thing that we're relying on. In addition to the buoy, we are using tools like structure from motion to build 3D models of the reefs and track changes over time. With this technique, you can zoom into these models and look at individual corals. You can measure them, evaluate their health, and you can also evaluate the microtopography of the reef and look at how the reef itself is changing over time. To complement this, we deploy underwater microphones called hydrophones to record reef sounds. And this will help us track the things that we can't see and measure with traditional means. These are things like snapping shrimp that make the crackling noise that you hear on healthy reefs. And this is important because some emerging research suggests that playbacks of these sounds from healthy reefs can actually attract coral and fish larvae to reefs in poor condition to help them recover. Our colleagues in the Florida Keys at the National Marine Sanctuary there are starting to test this out, and we're excited to see what happens. But we're not just focused on the shallow reefs. This summer, the sanctuary supported divers from the Deep Coral Reef Ecosystem Studies program to collect the first data for reefs below 40 meters at Swains Island and at Ta'u using specialized technical diving techniques. This team includes members from the U.S. Fish and Wildlife Service, Bishop Museum, University of Hawaii, and the Papahanaumokuakea National Marine Monument. This team has also established a monitoring station in Fagatele Bay to look at changes over time. And this is an important project because the sanctuary actually has more mesophotic coral ecosystem habitat than we do shallow reef habitat. But we know very little about their status and even less about their susceptibility to ocean acidification. Supporting research like this is important to help us look at all of our resources and improve their management. And through all of this, while we're doing the research, sanctuary staff continue to protect ocean resources through regular surveys and interventions to improve reef health. Sometimes that may be the removal of marine debris like this net, but it can also include piloting adaptation strategies. So one project with our local partners and the American Samoa Community College is testing whether manual seaweed removal at sites outside of the sanctuary that have been affected by coral bleaching to see if removing the seaweed can help the corals recover. This is important because algae grow much more quickly and they actually smother corals while they are still weak and unable to compete for space after bleaching events or while they are affected by pollution or other types of stress. We think that by removing the algae, we can prevent shading and abrasion and reduce the algae enough that small herbivores, little fish and crabs, urchins that can feed on smaller algae, we're hoping that they can graze and hold it in check. This would allow the coral to put all of its resources into recovery and growth. Our first pilot project showed some promising success, and we're hoping to see that continue in the future. We also work with the sanctuary's climate change working group to raise awareness about climate change, share information, and gather input from our own work, including upcoming climate vulnerability assessments. And as always, the sanctuary continues to educate our youth about ocean conservation so that they can continue to be good stewards of these incredible places. And so we're hopeful that we're going to find solutions, but we are using the opportunity with these healthy reefs to study them and to develop adaptation strategies. But the problem is still ocean acidification is coming. And so we need your help to protect these special places. I'm sure you've heard it before, but what you do does matter. You can think about reducing your carbon emissions in a number of ways by lowering your consumption. It's Christmas time, so maybe think about gifting experiences or handmade or local items instead of buying things. You can limit your air travel utilizing virtual formats for meetings, and even just reduce the meat in your diet. It can have surprisingly big impacts. Thanks for taking the time to learn about ocean acidification at the National Marine Sanctuary of American Samoa, and we hope that we'll get to see you here someday soon. Okay, there we go. That was my ocean acidification story. I hope you guys were able to follow along. I think there might have been some gaps there with the internet island troubles, but hopefully that was helpful. So I want to go ahead and talk to you about how I actually built that story out. A lot of times when I talk story with no particular aim in mind, just sharing experiences. But when it matters, when I need to get a point across, like today, really wanted to talk about ocean acidification and what the sanctuary is doing to understand it and to combat it. So when I'm trying to do something like that, I like to use this tool, and it's called a message box. It's a really great tool by a group called Compass, and it helps you distill your messages into the most important components and organize them in a way that allows you to easily pivot or respond to questions. This has been a life-saving tool when I've had cameras stuck in my face with TV news reporters or people reporting for the newspaper that like to pepper you with questions. By going through the process of setting up a message box, thinking about your messages and the points that you want to get across, you can be ready for that. And you can use it to help craft stories. So as I was building out my story for today, I went through this process. And so I want to share that with you guys. So starting off, the audience was all of you, my lovely SOARCE participants. Thank you for being here today. And we knew that the issue was ocean acidification at National Marine Sanctuary of American Samoa. So I have those starting pieces. I went through then to kind of define the problem. So what is the problem? Problems, carbon dioxide concentrations continue to rise, pH continues to decline, and aragonite saturation is also declining around the world. So what? Why is that important? It's important because of lack of action will result in a loss of biodiversity here at the sanctuary and other places. It'll decrease the ecosystem services, including food, coastal protection and heritage, and sense of place. So it's going to affect people. And it could cause the potential loss of iconic corals like Big Mama and Fagatele Bay. The benefits of those resources are particularly valuable because oceans and coral reefs provide a lot of valuable services to people, and they have for over 3,000 years. So that includes food, coastal protection, and cultural importance. You'll note I also have biodiversity and possible pharmaceuticals on this list, but I decided to leave them out of the story because it was a little bit off topic and not something that we're working on. Still a good thing to keep in your message box if you think that you might get questions about it. And then the last thing I have on here is solutions. And so the solutions are to ask you to help decrease your carbon dioxide emissions, to improve awareness about the issues so that people know what's happening, and to study the core of the story, that we're studying relatively pristine reefs to better understand what effects are ocean acidification versus pollution, fishing, and other types of impacts that corals face around the world. So using our sites as a lab to explore that. And then using that information to inform adaptation and restoration strategies. So this is a great tool. You can use it for any issue, any audience, and I highly, highly recommend it. But when we're talking about storytelling, we got to go another step beyond that. And so the first thing is they tell you is to create a character. And so that can be a lot of different options. It can include the viewer. You can bring them into the story. It can be yourself. It can be your team, your office. It could be something like a fish that you have wandering around. I could have chosen that little coral baby to be my character and guide through it. And what I ended up talking about was Big Mama. And I chose Big Mama because it's superlative. It's something that people associate with the sanctuary, and people are interested in it. It's exciting and special, one of the biggest corals in the world, and I just happen to also love it very, very much. Makes it easy to tell stories about it. Um, and so the next part of the story, you have your messages, that you want to get across. You have a character to carry that story. The next part is developing the actual story. And this is a little bit harder, but I am a big fan of the ABT method because it's simple and it's effective. It's easy to remember as well. So this is the and, but, therefore tool. And this is really described in depth by Randy Olson's book, Houston, We Have a Narrative, but it's also been highlighted by people like the creators of South Park for how they tell their story. So check it out. It's pretty simple to use. You introduce your character. We have an amazing coral. And then you tell people a little more to get them invested. So we have this amazing coral, and it does so many great things for fish and other critters, also for people. And it does this and this. So you build out that background using your and statements. But this is where you bring in the drama. Has to be some sort of issue or climax. But it is threatened by climate change and ocean acidification. So ocean acidification is coming for Big Mama after 500 amazing years. Oh no. And then we jump to our therefore. So the solution, what do we do? Well, we can't here as a tiny island shift carbon dioxide emissions too much, but we can use the sanctuary to understand why Big Mama and other corals in American Samoa are doing so well despite the impacts of climate change. And using these remote sites to evaluate human impacts at other sites and use that to help develop strategies. So there's our therefore, the so what, why is it important? And we also are going to ask our audience to help to magnify the effect of taking action. And so from there, you put that all together. You select your facts, your figures, your photos, you put those into your story, and you try it out. I ran through this with Natalie yesterday and Liz, and we talked about it. And then you refine it and bring it back again. And so that's it. That's my process. I'd love for all of you to maybe provide some feedback and ideas. I'm happy to answer questions about Big Mama or about the research that's happening here at the sanctuary. But I'd really love to hear feedback either in the chat or through the questions about your ideas. So was there anything that you really liked or maybe disliked? Was any of the information inaccurate or outdated? What would make this a better story? What would help you to either share this story or develop a similar story that you could tell? And especially for educators, what resources do you need to share information about ocean acidification or to bring it into your classroom? These are all the types of things that help folks like myself improve our stories and put that in. And to make this a little easier, we also have some polls, and we'll see if I can figure out how to use the polls that you guys can answer here. So we'll put up our first question here and see what you guys liked best. My first time using the polls function. We'll see how I do. Okay, looks like we're getting to enough votes. I'm going to go ahead and close this one. Get your votes in, and we will go ahead and close it here and see what we had. So we had 56% liked learning about Big Mama. So I did a good job picking a character. Hooray. And also the explanation of ocean acidification scored well. All right. Thanks for that. Let me see if I can figure out, let's see, my next poll question. And that is, were there parts of the story that were hard to understand? Was there something that I can do better to explain? Oh, I love whoever quickly said no, it all made sense. I'm just kidding. I love feedback too. So more explanations on the research. Oh, I might be biasing the poll questions. I'm going to stop here. And keep in mind, you can also put questions in the chat there. We'll see, trying to see. And let me see if I can expand that. Okay, now I can use the platform. Ooh, somebody knew 500. Oh, Claire, you're cheating. You know it. Okay. So I had a couple of people suggest, oh, somebody said that they thought Big Mama was 5,000 years old. A little bit off there. All right, so let me go ahead and share. Thank you, Natalie. We have the poll results there. So people would like more explanation of the research. So maybe I need to have a little more time to explain research there. That's great. Okay. And this is an important one for me, but an easy one for you to answer. How is the pace of the story? I have a very bad habit of talking too fast. So important feedback for me there to see if that was okay, if it was too slow, too fast. Okay. And I'm looking at your questions in the chat as we do this. All right, it looks like, okay, I'm so surprised. Okay, so we're gonna close this poll. We're getting up there. So 95% said it was just right, but 5% said it was too slow, which is surprising. I tend to go too fast. So thank you for that. And let's see, gonna have my next question. If I were to change the character, I wanna know about my character selection here. What would you pick if I were to choose a different character? And while you guys are thinking about that, I'm going to start answering questions. So I had a question about, based on my research and experience, do I attribute coral bleaching to OA or increased oceanic ambient temperatures? Definitely temperatures. Ocean acidification is still kind of a developing issue, but temperatures really seem to clearly be the driver for that. Okay. See, do we have any other questions coming in? Oh, I had one person make a suggestion on helping teachers with their storytelling is to provide teachers and educators with all the fun facts so that they have the and but questions. That's a good point there too. All right, so going to our poll question, it looks like you would like a fish, marine mammal, or sea turtle as the character. Okay, that's great. I like to anthropomorphize ocean creatures. So now you're giving me an excuse. And it's actually kind of, we could tie it in both, because while we were out in the field this year, we actually saw some of our humpback whales that have traveled all the way from Antarctica to come to American Samoa for breeding. We saw a mother and calf swim right past Big Mama. We weren't underwater at the time, we were on a boat, unfortunately, so I don't have footage, but it was pretty amazing, like some of my favorite animals right together. And it just shows how connected they are, which was a great option. So maybe we can work that into a story in a future presentation. I love that. Okay. And one last question for all of you. Were you already familiar with the tools presented, or was this something new for all of you? Oh, it's really mixed. Okay, we'll see how this comes out. So I learned about MessageBox a long time ago, and like I said, it's been a lifesaver. So I strongly, strongly encourage, if you haven't used it before, definitely check it out. I think the link is in the chat for you. Let's see. Still collecting some responses here. And I'm going to go ahead and close that. So it looks like they were new for a lot of you. So definitely recommend checking these out. They are incredibly useful tools to help build stories and to help convey narratives, to help people understand some of these topics. All right. And so those are all of my poll questions for all of you. And trying to see, Natalie, did I miss any questions in the question and answers?
Nope, you got the one question that we have. So we're now welcoming any more questions for Val in the question box that's on the GoToWebinar dashboard. You got some great feedback about using the storytelling approaches. And then you also have the guesses of the ages of Big Mama. So while we're waiting for some questions, given your experience using the message box tool, would you say for educators, is there a specific age range that, works well with using the message box? Perhaps could they, is there a too young age range? Would you say high
You know,
school?
I honestly don't think there is a too young, because the thing that MessageBox does is it just helps you refine your messages. It helps you really think about what you want to say. So even if your audience are 3-year-olds, you could say my issue is ocean acidification, which I think this might be a hard topic for 3-year-olds, but you could craft your messages, right? So I wouldn't try it for very, very young people. I do think for this topic, ocean acidification, it is a tough one to explain because it involves chemistry. To show it, you're looking at charts and interpreting graphs. So for this type of thing, it's easiest high school or up. For ocean acidification has been my experience, but I'm really wanting to shift that younger. And so because it's something that our team is struggling with here, is how to convey this in an easy and accessible way to our youth so that they can take action themselves, right, and be good stewards. So this is actually the first time I have done this presentation. So I have a question in there, who's your typical audience? This is the first time I've done this presentation. But I have worked with everything from school children in elementary school all the way up through retirees through my job. So really, I try to assess who my audience is going to be and use that tool like a message box to then tailor my talk to that audience. So if I know I'm talking to scientists, I can throw in all of the jargon and all of the charts and all of the data that I want, and they're going to be able to follow along. Versus if I'm talking to school children, I need to add a lot of pictures and images and keep my messages very simple. So yeah, great question there. And then, is there any research studying multiple stressors in American Samoa, the combination of OA and pollution? There is actually. The Pacific Islands Fisheries Science Center team just finished up some work in the Aua watershed, specifically looking at how pollution might be affecting coastal acidification. And so I didn't have time to get into that research today. It's outside of the sanctuary, but that Joy Smith is the lead for that. And I think having those comparisons of areas that are close to human populations here and looking at what is happening in those areas. And in fact, that picture I showed of what if, that's from her studies, like this from the study site there. It's been impacted by things and has not been able to recover. So they're actually trying to look and see what are the drivers of that lack of recovery in that place. So yes, very much so, looking at these different synergies. We've also been trying to get funding to look at modeling to look at what the future projections might be. We haven't quite gotten funding for that yet, so hopefully in the future. And then one more comment here talks about a shell dissolving in a vinegar mixture as a good younger ages presentation. And definitely I agree with that. Like anything that can help them see. I've also thought about like using like Tums tablets and acid to try to kind of convey that experience of something dissolving. And then a question there with that was, what is upcoming work that the sanctuary is working on to see how coral bleaching due to climate change and ocean acidification compound together and how it impacts corals? Great question there. That is exactly why we have that buoy in Fagatele Bay. It is why we are building out a really robust monitoring program, and we are actually crossing our fingers that we don't see coral bleaching next year, but we're ramping up to get temperature loggers in to do some long-term plots for that, using that structure from motion technique to be able to map out the corals in different spots of our sanctuaries, and then be able to follow those through the event and then follow them long-term. Also, that hydrophone is an important part of that that work too. So being able to over time track the ocean acidification parameters like pH and carbon dioxide in the water, along with how does the sound change, how do the corals change, and looking at the other stress events that are coming in. We've also done some evaluation with the National Centers for Coastal and Ocean Science on pollution within Fagatele Bay. So trying to definitely put all of that together to understand better. And that's really what's kind of driving our science program here at the sanctuary is understanding these big driving climate change factors and how we can learn from these sites to help others.
Great. Well, thank you so much for your presentation today, Val, and thank
Yeah.
you for your early morning start to join us on the East Coast time. We welcome any feedback, suggestions, or future speaker ideas, topic ideas for this webinar series. You can reach us at noaa.oceanacidification@noaa.gov. Our next webinar will be held on January 10th, Wednesday at 1 p.m. So that concludes the webinar series. I hope everyone has a great holiday season. Thank you again, Val, and have a great rest of your day.
Thank you.